pretty tough to keep up with, but I'm crying my best. Um, let's talk about the goals for this week. We really want to get started on the create task development. Um, who is? Let's see. I'm trying to remember. Oh, it's Hey Trong. How are you, buddy? Hi, Amir. It's good to see you, or sort of see you. Anyway, we want to get started on the create task development this week. You should have turned your explore task in as a draft. I went in there, I want to say Saturday, and looked, and I think we had maybe 12 people had turned theirs in as a draft. A couple of you had only submitted one thing as a draft. You didn't submit both your artifact and your written responses. So we need to make sure that that gets done. I'll start to kind of reach out to you more directly if you haven't turned your stuff in this week and say, hey, now's the time. Let's get it done. Okay. So as we begin create task development, one thing that is really important that you do, and it's one of the most challenging things you're going to do, is I need you to keep notes on when you are engaging in an iterative process. And when I say iterative process, I mean changing things over time to meet the requirements of a new problem, or debugging, those sorts of things. You really want to keep good notes on that as you go through, and I'll give you some examples. But if you don't, it's going to be hard to respond to the written responses that ask that question, and those answers have to be very precise with their language in describing a correct version of the iterative process according to code.org or College Board. Okay. We want to make sure that we work toward developing an algorithm that uses 2 additional algorithms when called. Again, we're going to look at examples of this. You should have already looked at the create task samples last week and should have some idea of what I'm talking about there, but we're going to go into more detail on this lecture. And then I want you to continue to reflect back on those samples from the create task. Those are a great resource for when you have a question on whether or not something meets the requirement. You need to go back and look at those resources to help you understand independently whether or not you're meeting the requirements. Because remember, there's a limit to what I can help you with as far as saying yes or no, this meets the requirements. Okay, I can help you some, but there's definitely limitations on that. All right, your deliverable for this week, your assignment is that I want to see what your idea is for the create task in Google Classroom. And that can be a really general idea of what you want to do. We're going to talk a little bit about idea generation today as well, but I would like to see a general idea of what you want to do in Google Classroom at the end of this week. Okay, and I'll post that assignment out there once we're done with the live lecture. At the end of today's lecture, we're going to have a quick Google Meet just so I can follow up with you on any questions in real time, and we can just see each other for a little bit. And I think that would be a good practice for us to start doing, is just to have our little meeting right after we have our lecture. I don't anticipate that this will last past 11:30, meaning we'll probably be done with everything around 11:45 or so. That's my prediction. Any questions about anything from last week and anything from this week before we move forward? And again, you'll have an opportunity when we hop on the Google Meet to ask other questions if you don't want to ask them right now or you're not sure yet. And another thing, before I move forward, I want to make sure that my volume is good, that you guys can see everything that you need to see. Any issues there, just let me know in the chat. Probably should do that before I go into a big spiel. Okay, I think I'm giving you enough time to kind of respond there. So If you have any questions, just throw them in the chat, and if not, we're just going to move on. So the first thing I want to do is direct you all back to this home base for all the resources that we have for the create task. Remember, that's in code.org. It's now assigned to you. So the create CT prep, or this unit right here, is now assigned to you in code.org. So it should be the first thing that pops up when you go into code.org, into our classroom. And you should be using this on a pretty regular basis. Because ultimately this is the most accurate and most available resource for you at any given time, is to go and look at some of these samples, to look at the scoring guidelines, all that kind of stuff. It's all situated right here. And again, you should be coming back here on a regular basis to see, are you meeting the requirements, right? This is your best resource. The first thing I want to look at briefly is the set of scoring guidelines, or the rubric basically for the create task. Okay, I don't want to go over this ultra in depth because I think that I would bore you to death, and you can look at it on your own time. I will tell you that what I want you to do with this rubric is very similar to what we did with let's see, I'm trying to situate this best here. I'll tell you what, I can move somewhere else. Whoa, 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 whoa. There we go. Okay, I'm going to go up here. Hello. So I will tell you that what you want to do with this is very similar to what we did with the explore task. We're going to use the same sort of philosophy in looking at this document as we did with the explore task. And that means really focusing on the exact language for each row, and making sure that we're not getting or hitting one of these do not points, right? You want to make sure that nothing about your response or your submission for that row, whatever it is, you want to make sure you're not falling under any of these bullet points, because that's where the readers are going to look first. They're always going to default to looking over here and seeing, did you fall into one of these categories with your with that row's response, whatever correlates to that row. So it's really important that you're reflecting on these as you go through, okay? I cannot overemphasize, now that we are not in the classroom anymore, how important it is that you guys independently on your own are in here just double checking your work, okay? This, again, we've only got the explore and the create task as our measure of success in AP this year. So it's up to you to do what's necessary to make sure you score well. Every person in the class could get a 5, simply based on the fact that we only have to worry about the explore and the create task. Everybody could get a 5. Okay. So let's go ahead and take a look at this. With the create task, you're going to be responsible for submitting a video of the program running, and you need some kind of audio narration or a written response that identifies the purpose of the program. Okay, so the video should demonstrate at least one running feature of the program. If you're making like if you're making a Python program and you're doing like a console application, it's going to be pretty easy for you to do this right here, because every element of the program will be a feature of some kind. But I would focus on a feature that actually makes your program interesting, right? Don't make a video about how your program prints off a header for your application, okay? Make a video about the most interesting feature you wrote, okay? It doesn't have to be the most complex, it just has to be interesting. Well, it doesn't have to be, but why would you not do that? Okay. Let's see. I guess, am I still in an okay place? Yeah, this looks all right. So this is row 1. And again, your response must identify the general purpose of the program and what it is attempting to do. It's very easy to earn a point here. Ultimately, you can only lose a point if you don't submit a video. It doesn't illustrate the feature mentioned in the response, so make sure that you're talking about the feature that's mentioned in your written response. And it needs to show that the feature is running. So screenshots or storyboards are not acceptable and would not be credited. It has to be a video that shows the code running. And I think they do that so that they see that you have submitted actual working code rather than just, you know, a bunch of gobbledygook that you sort of came up with that maybe or maybe does not work. Okay, so that's row 1. Row 2, you want to describe or outline steps used in the incremental and iterative development process to create the entire program. That's row 2, and that's response 2B. Okay, and then for response 2B, you also have row 3, where you're identifying at least 2 program development difficulties or opportunities, and you're describing how the 2 difficulties or opportunities are resolved or incorporated. Now, this is a spot where you can easily miss points if you are not precise with your language. And we're going to look at some examples in the samples from code.org where the language that the responder uses does not meet this iterative requirement. Okay? They don't talk about how their development process was cyclical, meaning they're going back and looking at things and reevaluating. They're reflecting and then revising. They're testing it out and refining their code. All of that has to be clear in your response. And so guess what? Just like when we talked about explore task, right? Using harmful and beneficial, we're going to use this language in our response. Reflection, revision, testing, and refining. Okay? You don't need to use some kind of formal method that we would use out in the real world, like waterfall, top-down, agile, right? You guys are all going to be probably agile developers unless you work for NASA or something, which would be cool. But you're all going to be agile developers. If you want to learn more about that, you can Google it. But code.org doesn't care, okay? They want you to talk about iterative development in this sense. And I'm going to show you some example code that I've written that kind of shows you this iterative process. But here's the thing. If you don't make the point to take notes of when you are running into issues, it can be in the code, you can write a comment, okay? It can be on paper, you can keep a little journal. If you don't make the point to write those notes, responding to this honestly, accurately, and without sounding like it's BS, it's going to be really tough. And really you only have to take notes about a couple things, right? Where you run into 2 development difficulties or opportunities, right? They want you to talk about that iteration in a real way. And so iteration, right, iterative development, always comes with an opportunity or a difficulty. So you need to find out, or you need to keep track of, 2 difficulties or 2 opportunities, and talk about how they are resolved or incorporated into your code. So, difficulties are resolved, opportunities are incorporated. But you have to tie those back to an iterative process. And we're using this language, I know, right? We're saying iterative, incremental. You can think about iteration kind of like we would iteration, that's for loops and while loops as far as code is concerned. And that's sort of what we're talking about right here. So iterative development is one that's cyclical, just like a loop, right? We're always going through a sort of feedback loop where we reflect on our code, we revise that code, we test it to make sure it works, and then we refine it further. And we're always doing that with our code. All right, I've dwelled on that for a while. That's row 2 and row 3. Okay, for row 4, you need to select a code segment that implements an algorithm. Remember that an algorithm is just a series of steps, so most code will meet this requirement for row 4. But it won't if it only consists of a single instruction. The code segment that has the algorithm is not included in the written responses section, or it is not explicitly identified in the program code section. You have to explicitly identify which one it is you're talking about, And you do that with some shapes. So we're going to end up like drawing on this, and we'll kind of come back to that later when we really start to talk about submission. All right, let's see. Now, the two most difficult points to earn on the create task are row 5 and row 6. Row 5 is easier. Row 6 is actually very difficult. This row 6 right here, well, you know what, let's do row 5 first, and then we'll talk about row 6. So the code segment that you select must include a mathematical or logical concept. So mathematical would be anything using math. A logical concept is anything using like value equals 7, or you have some kind of, you know, like an and or statement or a not statement. Some combination of logic, right? Remember, logic is just true, false. Is it, you know, is this true? Do this. Is this false? Do this, etc., right? If else, that kind of thing. Your written response must explain how the selected algorithm functions and describe what the selected algorithm does in relation to the overall purpose of the program. You can, for this row, use existing language functionality or library calls. So what does that mean? That means like a print statement. Okay, a print statement is built into Python. You did not write that code to create like a print statement, right? You didn't write the code to get the length of a list, unless you do that yourself. But if you use the len function in Python, that is not that's not something you developed on your own. That's existing language functionality. So you could do that. You could say, you know what, for row 5, I'm going to use an example where I'm just using something from Python. I would strongly encourage you not to do that, because in order to meet row 6 and in order to meet some other points, row 7 and row 8, I think, you need lots of stuff that you have written on your own. Okay. So you might as well, when you're selecting a code segment here, you might as well use something that you wrote on your own, rather than saying like, hey, this is the len function, because then things get more complicated for the reader, right? The reader is going to say, okay, well, I shouldn't award a point if the selected algorithm consists of a single instruction. So if you're just calling the len function, well, that's really a single instruction. Oh yeah, this is right. Okay, my bad. So let me rephrase what I said earlier. You can utilize existing language functionality, but it can't be the only thing that you've selected. So that's my mistake. It can't be the only thing that you've selected. You can use existing stuff. It just can't be the only thing in there. Okay, it's my bad. All right. You need to have mathematical or logical concepts, like we said before. Your response needs to be very precise in describing, you know, what's happening with the code, why it's written that way. And that brings up another point of try not to avoid writing code that is extremely superfluous, meaning don't try to meet these requirements with code that doesn't otherwise make sense. Your code should sort of naturally fit with the rest of the program as best you can. Sometimes it's going to be tough depending on what you choose for your idea, but it's always possible, I think. And here are some notes about like what they mean by logical, mathematical, iteration, selection. So iteration, we're talking about looping. Selection, we're talking about if else. It doesn't talk about sequence on here, but you do want to avoid just having an algorithm that only has sequence, because it's going to be difficult for you to meet the other requirements. I mean, if all you're doing is saying my code runs from top to bottom, it's going to be difficult to meet the other requirements that are here. Instead, make sure you're including some kind of selection or iteration in the chosen algorithm. And guys, keep in mind that when I'm talking about this specific algorithm, this is only one part of your code. You know, you can have a project that's 400 lines of code long. This could be 8 lines that you've selected. Okay. It only has to be one algorithm that meets the requirements specified here. All right. So that's row 5. Row 6 is the hardest point to get. And the reason that is because row 6 requires that that algorithm you have selected implements an algorithm that includes at least 2 or more algorithms. So basically, you need, for example, a function call, or you need to define a function that has some kind of algorithm in it, some kind of if-else maybe, or a little bit of sequence. And then ideally, that function that you have defined should call 2 other functions, and at least one of those algorithms uses a mathematical or logical concept of some kind. So you have a parent algorithm and 2 child algorithms. You have one parent algorithm that has 2 children to it. And we're going to look at some examples of that in a minute. Okay, so again, very similar do nots for this one. You shouldn't have just single instructions. You shouldn't have just live calls to existing functionality. You have to use at least some mathematical or logical concept in one of the child algorithms. And yeah, you got to explain it. You got to explain the correct one. Okay, so as you can imagine, just reading this, right, it's easy to get a little bit confused. You're probably getting a bit confused as I'm talking about it. Understand that the AP reader is, unless they're very experienced, they're going to have trouble interpreting this as well. So my comment to you is that you need to make every effort to be abundantly clear about what it is that is meeting the requirements of this portion. Okay, so when you explain your code and when they look at your code, it should be extremely evident that you meet both of those rows. Okay, again, don't leave anything up to the reader's inference. All right, for row 7, the selected code segment that you have. Let's see, this is let me scroll up here real quick. So this is code segment in response to C, okay? So all of these, row 4, row 5, and row 6 apply to C. That's one code segment. Another code segment that you're going to submit for response 2D must be an abstraction that you developed. What's that mean? It has to be a function that you wrote, okay? You guys shouldn't have any trouble meeting this row right here because you should be writing plenty of your own functions for use in this code. And the last point, and perhaps a more difficult one to get, is you need to explain how the abstraction that you wrote manages the complexity of the program. When we're talking about managing complexity, we're talking about things like, does it prevent us from repeating ourselves, right? Are we writing a function that prevents us from having to write the same code many, many, many times? You can explain that. If you say that it manages complexity by organizing the code, you can say that as well. Lots of opportunities here to explain how you managed complexity with that code. Okay. All right. So I want you to kind of jot down any questions you might have on this right now. I'll give you a couple minutes. If you've got them, you can put them in the chat, or we can circle back to that during the Google Meet at the end. Okay, so go ahead and do that right now. I'm going to pull up the next thing we're going to look at, which is a sample, and this is going to be sample F from code.org, and you can pull it up too if you'd like. And we're just going to go through this really quick. And then I want to talk to you about the iterative process, and we're going to look at more of these samples and more code each week as we continue with the create task. Okay, your all's biggest goal this week is really just figuring out what it is you want to do with your time working on the create task. But I do want to go over a little bit of this today, just so you can kind of get a sneak preview. So again, if you got any questions about the scoring, the rubric, make a note. Does each response section need to be a different code section? Eric, that's a great question. So I'm going to go back to this real quick. Notice that we've got, Eric, we've got response 2C, okay? And that applies to 3 rows, row 4, row 5, and row 6. And then we've got code segment in response 2D. That applies to row 7 and row 8. So you will have a total of 2 code segments that you're talking about. You can include more code. For example, like if you want to talk about a specific algorithm with your response 2C, but you need other code to sort of contextualize that so it makes sense, you can include that. You just won't highlight it, basically. But ultimately, to answer your question, each response here only contains 1 code segment at a minimum. So this code segment for response 2C, it's going to be the same one for all 3 rows. And this code segment for response 2D, it's going to be the same for rows 7 and 8. Okay, Preston, do we have to do written and video? Is there one that's more recommended? You must do a video of your program running. You must. And then you're going to have a written response or audio narration that follows along with the video. So you must have a video. And I will show you all, for those of you that don't have like, you know, some kind of streaming gear, or you can't, maybe you don't have a webcam or something like that, I'll show you how to use a software called Screencast-O-Matic. I think that's it. It's either Screencastify or Screencast-O-Matic. Maybe it's Screencastify. Yes. So Screencastify is the free version that you can use to record your screen. And I'll show you guys how all that works when we get closer to doing the video stuff. Any other questions right now? Okay. So remember, you all got to check these samples out on your own and kind of read them and see why this person didn't score here. This can get really nuanced, especially for those. What the heck was that? I don't know. Something just went off on my screen or on my computer. These can get really nuanced, and that's not how I want to do that. Sorry. 200. Oh yeah. All right. Cool. So when we're looking at these, especially when we get to row 5 and row 6, as you can see, they did not score there. Reader's interpretation can really make or break your response here. So it's important that you are explicit, you're clear, and your algorithms really meet those requirements. You know, obviously. Okay. So, you know, you don't get to see the video here, but we've got a video of a cat clicker game. I told you guys already, don't make clicker games. They don't end up doing well because there's existing bias against them, and it's going to be harder for you to write your algorithms, I think, in the end, that meet the requirements. So they earn a point for this row because they did a video and they provide some kind of written response or narration. And here's their written response. So blah, 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 blah. They say this program is a clicker game. It states the purpose. And then it says the goal of the program is to click the, I don't know if it's Nyan or Nyan cat, I can never remember, as many times as possible to get a higher score every time in 30 seconds. That does not make sense, but they did the bare minimum here. They explained the purpose. Moving on. All right. This is where this person is trying to describe the incremental and iterative development process of their program. You want to focus on 2 distinct points in that process. describe the difficulties and or opportunities that you encountered, and then say how they were resolved or incorporated. You need to clearly indicate whether the development described was collaborative or independent, and at least one of these points must refer to independent program development. Now, we have not talked about this point a lot. You are permitted to collaborate on a program. If 2 of you, 3 of you want to work on the same program, you can. However, the code segments that you choose to share with College Board in your responses must be completely independently developed. I will tell you that it is abundantly clear to almost any, I would say teachers included, like not just programmers but teachers, right? It's abundantly clear when plagiarizing or even small elements of copying are taking place. Because even though you can have the same goal, no 2 people solve a problem in exactly the same way. And with programming, a lot of it comes out in like variable names or small mistakes that have been repeated. So they can see it pretty quickly. I'll see it quickly, and I have to mark you as plagiarized, and there's nothing, and that's it, right? We can't revisit it. I can't call you up and be like, hey, don't plagiarize, try again. It's over, okay? So you won't get a score. And because we don't have the luxury of the multiple choice exam, I mean, you guys can look at this one of 2 ways, right? The multiple choice exam could be really easy, and that's a benefit, or it could be like, the multiple choice exam is the chance to mess up what you already did really well in this class. So like, it stinks that you have to take an exam and mess all that up. You guys might view it differently. It just depends on your perspective on that kind of stuff. But don't squander your chance to score well because you are plagiarizing, even if it's not intentional, right? You need to be really aware of what you're doing. Okay, so anyway, at least one of these has to refer to a problem that you solved independently, and you need to be very clear about how you're describing the incremental and iterative design process. So you're going to see that this person talks about 2 difficulties and opportunities, or and they actually get a point for that. Okay, so they say setting the timer to count down 30 seconds and stopping the time when the pause button was clicked was one problem that they had. They figured out how to do that and fixed it with a function called time. Okay, so there they go. They made an independent development that was an opportunity, or excuse me, a problem, and they talked about how they fixed it, right? And then they had another problem where they wanted to update the high score the user received every time the score was higher, and then they resolved that by adding an if statement, blah, 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 blah. Okay? They never talked about how they reflected on that process, how they went back and revised existing code. Really what this person said was, I had an idea or I ran into a problem, and then I fixed it. And they didn't talk about their thought process. They didn't talk about what they tried. There's no reflection, no revision, no suggestion of iteration. Okay? Right there. Okay, the reason code.org says this one did not score on this row right here is the response does not explain if the problems were solved using an iterative development process. Okay, and we've talked about this like philosophically in class before. All the joy in programming comes from the process. We all feel great when we solve the problem. We all feel great when we get to the finish line and it's done. But I would wager for most of the stuff you're passionate about in life, and it might not be this, and it doesn't have to be, but the things you actually care about in your life are the things where you enjoy the process, even when that process sucks sometimes. You get more out of the process than you do the result. The result is kind of an afterthought. Okay? It's kind of like, say you're running a half marathon. You want to run a half marathon. Okay? All the training that goes into that, building up to 12 miles, or whatever it is, 13.1? Yeah, 13.1 miles. all the training that goes into that, right? When you cross the finish line of the half marathon, you're not like, oh, I finished the half marathon, as much as you are like you're taking so much joy in the fact that all that work brought you there. If you just walked out of your house one day and ran a half marathon, it wouldn't be the same, right? It wouldn't feel the same. So again, you need to talk about the process. You need to talk about all the training that you're going through, and that's why you have to take notes, because if you don't take notes, it's hard to talk about. Okay, moving on. So we're for 2C, this is the algorithm that we are selecting. It's the one that has to have a parent and 2 child algorithms, and we're going to see that they do not meet that requirement for row 5 and row 6. So for row 4, all you got to do is select something that implements an algorithm. So as you can see, it's pretty evident that there's an algorithm here, right? There's a step-by-step process that's doing stuff. But code.org points out that all this algorithm contains is sequencing. So we recommend also including selection and or iteration. The reason they do that is because it's a lot easier to end up scoring for row 5 and row 6 if you're using more complex stuff, right? All this person really did was have a bunch of sequence. This code comes from the code.org app lab thing, and you can see it uses these on events. So basically what's happening is that on an event, meaning or on a click of the cat, it's going to set the position of the cat somewhere new. These are XY values. Okay. It's going to get text. It's going to increment the score, and it's going to set the text with that new score. Okay. That's not complex, but they still meet row 4. All right. For row 5, this person, for this row, the selected code segment needs to implement an algorithm, just one, that uses math or logical concepts, okay? So, they do include math minimally. Even they don't end up scoring, but they include math, right? Because they say score is score plus 1. There's some math, and really that's okay. It explains how the function works. When the event handler cat image was called, it executes the code in the event handler. When the cat image was clicked, it adds 1 point, blah, 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 blah. So it explains how it works, but it does not describe what this algorithm does in relation to the overall program. So something that you could say there, right? And I know maybe you're like, well, why does it not describe that? Well, really, we don't know why it matters. From this response, we don't know why it matters that when we click the cat, something happens. What should have been said here was the purpose of the cat program, again, is to get the max score. And so, again, this is why we don't do clicker programs, because their purpose is borderline meaningless. But you could say like, it lets the user see that their score is going up because the purpose of the cat clicker game is to get the highest score possible. And that's how you would relate that algorithm to the overall program. That's one way of doing it. Again, the more purpose that your code has, the more purposeful it is, the easier it is to talk about stuff like this. Okay, row 6. They don't get a point here. At no point are 2 additional algorithms clearly identified which are used by the selected algorithm. The 2 included algorithms must be defined and explained in addition to the selected algorithm. So if we scroll up, the algorithm they chose is this long series of stuff, but they're actually all independent algorithms. Okay? Now, if what this student was saying was that maybe it's this one, it's really hard to tie these two together. But what I want to point out to you is that on event is an algorithm, right? And set position is also an algorithm. Get text is, set text is. But those are all built in to code.org. So you guys wouldn't know that, but set position, get text, and set text are all built into code.org. as is on event, okay? And these are not really identified or talked about in the student's response as children of the on event. Honestly, what this person did is they included a bunch of stuff, like they've got a bunch of code here, but they just didn't explain it well enough so that it's clear to the reader that these algorithms are somehow related to one another. And honestly, that relationship is pretty tenuous because you would have to explain how set position works. And because you didn't write set position, it's kind of tough to talk about it in depth. So this is why writing your own functions and making sure they meet the requirements is really key. Okay. I want to point something out to you guys, and you probably have already noticed it. It's that, this student, they submitted this code segment right here. They scored on some stuff, right? So you can get, some bare minimum code segments in there and still score some points, but not score later on. Okay. So this is sort of it's not an all-in-one. It's not like it's not if you fail row 5 that you don't get points for row 4 or row 6 or whatever. It's that you can meet row 4 because you selected an algorithm, but then you might not meet row 5 and row 6. Those are independent points. All right. And then let's look at row 7 and row 8. They do earn a response, or they do earn a point for this row. And that's because they wrote their own time function. Now, this is an example where they might have been able to talk about like one algorithm that implements child algorithms. We've got these if statements here. We got another if statement. This might have worked out, like set key value. That if they had talked about that correctly, they might have gotten away with it. But they do select something that they developed on their own. Okay, so they get the point for that row. And let's see. They also earn the point for where they explain how the selected abstraction manages complexity. They say that we want to use the time, or I built the time function, and I implemented in the event handlers so that the code is reduced and not being repeated on certain event handlers. There you go. That's all you needed to do. Notice too, as you guys are looking through these responses, how much of the response is actually highlighted. So look at that. That's a pretty big chunk right there. Okay. Here. This one has more. But I want you to notice how much extraneous language this student uses when really the reader was ultimately looking for just this minimal amount. Now, like this one, another problem, blah, 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 that makes sense, right? That we have to have that language. But this one especially down at the bottom, right? A lot of this is extraneous. It's not really necessary to describing, or excuse me, it's not necessary to meeting the row's requirements. Hopefully that makes sense. Okay. That's pretty much it for this sample. I want to show you all one last thing before we transition to the Google Meet. But I want to pause here for a second and see if you have any questions about what we went over with this sample response. Okay. I'm going to keep going. I want to show you a quick example of how you can talk about, or how you can sort of discover iterative development on your own. And hopefully this is clear. And I thought about like writing the code with you in the lecture, but I decided I think I'm just going to show you what I wrote and kind of talk about how it shows iteration and maybe what you're going to experience when you go to write your own code. Okay. So this is a really basic journal. Let me move my camera again. This is a really basic journal program that I decided to make. And I tried to think about things that you might want to make right now. Things that relate to something that could like actually bring value to your life right now. And again, your programs don't have to be really or they don't have to be serious or anything, but they do need to be purposeful because it's easier to talk about purposeful programs, I would argue. And that purpose can vary, but a clicker game, I mean, a clicker game's purpose is just so, I don't want to say elementary, it's not the right word, it's just, it doesn't leave a lot of room for discussion about purpose. But anyway, what I want to talk about here is iteration, really. And notice that for my first iteration of this program, for this journal, it's very basic. It has no abstractions. Okay, it's just lines of code, no functions or anything like that I've written. Or it also doesn't meet any of the complexity requirements. So if I run my code, I hope it works. It says, "Welcome to your journal. What would you like to share today?" I love bananas. And my entry so far is that I love bananas, okay? And it'll just keep asking, blah, 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 blah. There it goes. And then I can quit, and that's it. So that's that program, okay? You could start writing code about your idea with something that is this simple. And that's a good spot to maybe pause and say, okay, what is an opportunity? What is an opportunity for this code? Why am I thinking about that opportunity, right? I'm going to reflect on what I've written. I'm going to take a note about that reflection. I'm going to say, hey, I found an opportunity. And now I'm going to engage in some refinement. Okay? So then I'll bring up iteration 2 in my REPL. And I said, okay, well, in my first one, I said I just have journal entries, right? But now I've got entries that also contain my mood for that day. It's just like a mood tracker. And then I'm also entertaining this idea of keeping track of some points as I journal. And then maybe I can get build up points over time and reward myself, sort of add this gamification to my journal where I'm being rewarded for journaling more and more because it's a good habit, right? And then this adds some display elements. So blah, 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 blah. My mood is happy. Hopefully I don't throw an error. And then blub, blub, blub. I'm sad. And I'm going to quit. Okay, well, I guess this doesn't work as well as I thought it did. Oh, it was printing them off. Yeah, there we go. So anyway, I can check my points. Let's see if I have some journaling points here. I have 2 journaling points, right? This is still a really basic program. Again, I haven't created any of my own custom abstractions. I have not written a single custom function for this code right here. So, I'm still not necessarily meeting the requirements. I don't have enough to talk about yet, but I do have some iteration to talk about. I've explored an opportunity. All right. Between this and the next one, I've done more reflection. I've thought more about what I want this code to do. And now, I'm leveraging some of this knowledge that I've gotten over the past couple of years, and I'm making a more robust program. So this is going to be a big jump. I don't want to dwell too much on the complexity of it, but I want you to kind of see where we could end up. And again, I said iteration 3 ... because this is way more than you would get out of 1 or 2 cycles of iteration probably, but I ran out of time, so I'm doing my best. Anyway, so this is iteration 3. Notice that now I've got my own abstractions. That's probably the first thing that you've noticed is I've got a bunch of functions. I've even got a class where I just said, every entry is going to have a text and a mood associated with it. So I'll have instances of entries. I'm going to have a get entry function that has this while loop and does some cleanup on the strings, that kind of thing. I've got this algorithm here. This is an algorithm that has one child algorithm. Okay. But what I want to draw your attention to is not all this extra. So there's a bunch of stuff in here. And we can come back to this code later and maybe look at it more in depth, just for more examples. But what I want to draw your attention to is what actually, out of all this code, right? I've got all these functions, all this stuff, and I've got a real working program, right? All of that is stuff that doesn't necessarily meet that parent and two-child algorithm part of the scoring guidelines, but this does. Okay, so when I call my update points function here, what I'm trying to do with these functions, or this function right here, is I want to see did the user make an entry, and if so, I want to give them some points. And then if they are at a certain number of points, I'm going to find out, are they on a streak? Like, are they journaling, several days in a row? I'm going to give them some extra points for being on a streak. And then I want to show their points, and then maybe a little message depending on how many points they have at that point. Okay, points and point. So update points is an independently developed abstraction. It has an algorithm within it already, but it also has these two very evident child algorithms, which I am including with my update points function. So if the person's last entry was not a blank entry, so they actually put something in, they're going to get 1 point, and then we're going to calculate final points. But in order to do that, we have to go to a child algorithm called checkStreak. And checkStreak, notice how each of these includes some kind of mathematical or logical component. Okay. So if points is greater than or equal to 5, I'm going to add 5 more points for like a bonus point. Otherwise, I'll add 10, and then I'll return points. Okay. So this value is going to get stored in final points. And then I'm going to call another algorithm, display points. Again, these are all custom defined functions. So display points is going to come down here, and it's going to say, okay, if points is greater than 0 and points is less than or equal to 10, that's a logical component of this algorithm. It's going to say, let's go, good job. Otherwise, if it's greater than 10 but less than or equal to 20, I'll say, journal boss, let's go. I don't know why I used let's go in both, but I did. And then otherwise, I can't even count these points anymore. Okay? So that's a good example of really thoroughly meeting that parent and two-child algorithms row. And you just need to be able to accurately explain why you're doing that, what that accomplishes, and what its purpose is as it relates to the larger program. Okay? The purpose of this is to show the user some points, to add this sort of gamification, kind of make it motivating for them to continue journaling, right? But update points is the parent algorithm. And the two child algorithms are checkStreak and display points. And both of those algorithms include elements of logic and elements of math. Okay? That would meet all the requirements. So you've got to think about when you're thinking about your idea, where in that program is something like this going to exist that meets that level of complexity and meets all those requirements. Okay. I know that's a lot. We have plenty of time. It's only April 14th. We still have a month before I want you guys to have this done. Technically, we've got a month and a half, but remember, I want it to be done on May 15th just in case not everything goes according to plan, okay? What I'm going to do now is I'm going to transition over to the Google Meet. So I'll go ahead and throw that in the Slack. It's already on Google Classroom if you need the Meet link. And then you guys can we can see each other, and I'll answer any questions you have about what we've talked about today or anything else that's going on, okay? So I'll end it right here, and then I'll see you on the Google Meet.